Hi, everyone. We're going to next read section 7.3 and 7.4 from Abramson. And this is our next part of trig at the beginning of the semester. Again, we're going to come back to it at the end of the semester. And in our sections 7.1 and 7.2, we learned how to find the trig ratios of special angles and right triangles. So we had right angle trigonometry. Right, and so we learned that, for example, if you wanted to find cosine of pi over 3, then you draw a right triangle. So we have a 90-degree angle with a little square in there, and then pi over 3 has to be one of your angles, and it turns out that pi over 6 is the other angle in the right triangle to get up to your full measure of angles. And so in this special triangle, the way I do it is I memorize these special triangles because I can figure them out again if I forget. So the way I memorize it is with the hypotenuse of 1, and then you can figure out from there, you have this side as 1/2, and this side over here is square root of 3 over 2. My picture's not great, but that's essentially what it is. And then cosine of pi over 3, right, is the adjacent over the hypotenuse. This is how we learned the right angle trig. So this is adjacent over hypotenuse. And so the hypotenuse is 1 and the adjacent is 1/2. So this is 1/2 divided by 1, but anything divided by 1 is just itself. So cosine of pi over 3 is 1/2. Okay, that's how we learned right angle trig. Okay, what if your angle is too big to fit in a right triangle? What if your angle is too big to fit into a right triangle? Right, so again, stepping back for a moment to degree measure of angles, because for most people, that's what you're more familiar with. For example, what if your angle is 120 degrees? Okay, which again, we're trying to convert over to radians. This is 2 pi over 3 in radians. Okay, an angle of 120 degrees. That's bigger than 90 degrees, right? So maybe it looks something like this. This angle here is 120 degrees. And so you can make a triangle with that angle, but you can't fit a right angle in it, right? Because you can have at most 180 degrees. 90 degrees is too big, so you can't have a right triangle. Okay, but we still want to figure out our trig ratios. What's sine or cosine of 120 degrees? Okay, because we want to be able to go all the way around the circle, essentially. Okay, and here's this crazy idea. It's something that happens all the time in math. Mathematicians are very, very used to this. We do it all the time. Most people outside of math are a little uncomfortable with what we're about to do. Okay, so we say we can't use right angle trigonometry to find cosine or sine of 120 degrees. And so we're going to take that definition, the SOHCAHTOA definition of sine and cosine and tangent, and we're going to replace it with a new definition for sine and cosine, and tangent, etc., secant, cosecant, new definitions for sine and cosine that will be the same as the right angle trig definitions when your angle is small enough, but will also be defined when you have a bigger angle. Okay, so we want new definitions of the trig ratios. So we're going to redefine the trig ratios, sine and cosine, etc. How are we going to do this? So first we're going to take our unit circle and we're just going to situate that same right triangle inside of a circle. Okay, I'm going to try again to draw a circle. Let's see if I got it last time to pop it into a real circle. But anyway, and then I'm going to add in my axes here, x, y. Okay, and what I want to do is I want to take this, probably my triangle up there is not very good. So I'm going to draw this same triangle, same right triangle, but inside of our unit circle. Give this a new color. Okay. So I'm going to draw the same triangle that we were working with before. It's got a right angle over here. This angle over here was pi over 3. Here was pi over 6. Okay. This has radius 1. So this circle that I've drawn is something called the unit circle, and unit circle only means it's a circle of radius 1. Circle of radius 1. And we use the unit circle all the time because we mathematicians tend to be lazy, and when we're working with this stuff in trig, we often have to divide by the radius. And when the radius is 1, that means we don't have any work to do. So this is why we like to use the unit circle. And so this is a circle of radius 1, which means that all these values where the circle hits the axes are 1. So this is positive 1 in the x direction, this is positive 1 in the y direction, it's negative 1 in the x direction over here, it's negative 1 in the y direction down here. It's a unit circle, it's a circle of radius 1. Okay, so what we're going to do now is we've just drawn that same exact triangle over here inside our unit circle, and what we're going to do is we're going to notice that this point up here on the circle, again, I'm going to use this language, it corresponds to the angle of pi over 3. And that means pi over 3 has to be in standard position, starts on the positive x-axis, right? We draw our angle out from there. And then the terminal side of that angle hits the unit circle at a certain point. And that's the point that I'm talking about, this point that corresponds to this angle of pi over 3. Okay, pi over 6 is also in the picture, but pi over 3 is the angle that we're talking about. And we know the hypotenuse is 1 because we're on the unit circle. But now we can see what the x and the y values are for this point that's on the unit circle. So, for example, what's the x value of this point? The x value is the same as this distance here, right? And we already know from our picture that we drew before that that distance is a distance of 1/2, right? And that's the same as how far did you go out from the axis out here? That's the x value of this point. And then the y value of this point, let's give it a different color, right, is this distance here, right, which we already know from our picture up here is square root of 3 over 2. Square root of 3 over 2 is the y value of that point on the unit circle that corresponds to this angle of pi over 3 in this particular way. So those same distances, right, that are the lengths of these sides of the triangle, square root of 3 over 2 and 1/2, right? Square root of 3 over 2 is the length of the side of the triangle, but it's also just the y coordinate of this point, right? It's how far away from the x-axis is it. And this distance here, 1/2, is the adjacent side of the triangle to pi over 3. It also happens to just be the x value of the point, this point on the circle, that corresponds to this angle pi over 3, right, when you put this angle into this standard position, okay? And so now what we're going to do is we're going to do these new definitions of sine and cosine. That if you happen to know this information about your angle and the corresponding point, right, make these definitions super, super, super easy, okay? So in particular, sine of an angle theta is just the y value of the point on the unit circle corresponding to the angle theta. Again, corresponding means you're in the standard position, right? That point is where that terminal side of the angle hits the unit circle, right? But it's just the y value. So if you know that point, you just grab the y value, that's what your sine is. Cosine of theta is the exact same thing, except that it's the x value. Okay, so I can use my handy dandy tools here. Copy, come down here and paste it, right? And then change this to x. Okay, it's the exact same definition. Cosine of theta is the x value of the point on the unit circle corresponding to this angle theta. Okay, so a couple of notes about these definitions. Like I said before, we use radius 1 because it's super convenient. We don't have to divide by the radius. But if your radius of your circle is not equal to 1, is not equal to 1, you need to divide by r. So those definitions become slightly more complicated. You have to divide by the radius. And that's what's going to make it the same no matter how big or small your circle is. Okay, and then of course tangent and also secant and cotangent you just define from the sine and the cosine. So tangent of theta is always sine of theta divided by cosine of theta. And in this case, it just becomes y over x. Okay, let's look at an example. So suppose you have a circle of radius 1. And to indicate that it's radius 1, I'm going to just draw in my little ones here, right? This is supposedly a circle, right? 1, 1, minus 1. This is a circle of radius 1. And let's suppose we have an angle theta that comes out here somewhere. Theta. It is something like this. And again, that terminal side, when we start over here on the positive x-axis, intersects our circle at this point. And let's just say we know because somebody told us that this point on the circle is minus 3/5, right? We know it's going to be a negative value in the x direction because we're on this side of the y-axis, and it's positive 4/5. We know the y value should be positive, so that makes sense. And we just want to know what's sine of this angle and what's cosine of this angle. So sine of this angle, well, sine of theta is just the y value of that point corresponding to the angle theta on the unit circle. So you just read it off. Sine of theta is 4/5. That was really easy, right? Cosine of theta is the x value of the same point minus 3/5. Let's say you want to find tangent of theta. Right, this is sine divided by cosine, so this is 4/5 divided by minus 3/5. So it's 4/5 multiplied by the reciprocal, minus 5/3. Cancel those 5s. So this is minus 4/3. That's all you do, just read them off, right? And so those definitions are the same as our regular right angle definitions if your angle is less than 90 degrees. But if it's bigger than 90 degrees, we need a new definition. So we'll use this definition, which lines up with the old definition when you need it to, but gives you a way to expand these things out. Okay, so I hope that helps. And then you'll get to see how that works with angles that are in the same family as our special angles. And so the values will end up being exactly the same as what we call the reference angle that's in that first quadrant, which is why we say you only need to memorize the first quadrant, except that it might change sign, right? Because depending on which quadrant you're in, whether the x value, which is your cosine, is positive or negative, or the y value, your sine, is positive or negative, right? Tangent, you're dividing them, etc. Okay, I hope this helps. Again, remember, you're going to have to go through this over and over and over and over and over again, and that's totally a normal part of the educational process. So be patient with yourself. And keep at it. And you're gonna, as you practice lots and lots and lots and lots, you're gonna become more and more familiar.